different style podcast. Decided to try a shorter format podcast where I try to update more regularly, where we just visit topics that are kind of happening now, if you will. So this is Denver Black with Soil from Zambia, coming to you to discuss today something that's very much in the forefront of our mind in agronomy, regenerative agronomy here, which is water and or drought stress. Here in Zambia right now, we're experiencing a severe drought, and as such, actually our water source through the Zambezi River and Lake Kariba, as well as some other, but that being the chiefmost one, Lake Kariba being very low volume, and so we're only able to generate so much power, and as a result, we're experiencing load shedding, which are periods of time throughout the day where they'll actually turn the power off. So, for example, today we lose power at 2 p.m. and it comes back on at 10 p.m. And so right now we're experiencing load shedding of 8-hour intervals. So for 8 hours, we can't run pumps. So for those of us who are irrigating out of a river, we're impacted because we have a reduced amount of time to irrigate. But also there are many here who are experiencing just reduction in water as well. Boreholes or reservoirs are just not as full enough as they should be. And that means we can plan ahead. We're getting ready to sow our crop here, and we know that we're going to experience shortages of water, and that spells drought stress for our crops. So that being said, I thought we'd dive into drought stress. So there's a few things that we can address that significantly reduce drought stress. So I'm just going to highlight a few article headlines here and findings, and I'll have the citation as well as the link in the show notes. So just for instance, starting off with soy hydrolysate, plant hydrolysate. So soy amino hydrolysate is something we've been using for ages. It is in all of our foliar blends for sure. And we know that amino acids like glycine from soy hydrolysate are extremely plant absorbable and beneficial to plants nutritionally. But as it turns out, they're actually very effective at reducing plant stress. So here in an article titled "Vegetal Protein Hydrolysate Reduces the Yield Loss in Off-Season Crop Under Combined Heat and Drought Stress," the study here revealed that the application of pH plant hydrolysates significantly improved the membrane stability index, relative water content, total chlorophyll and protein content of leaves. So it consistently led to an increase in the number of soybean pods in soybeans and chickpeas and fruits and chilies, leading to improved yields where plants were treated with the appropriate amount of plant hydrolysates compared to under the treatment of plants. Plant hydrolysate helped improve the efficiency of the photosystem too, which significantly high photochemical efficiency. So what it's saying here is it helped the plant to utilize its physiology that it already contains. It increased its physiological response to this stressor, and it increased in the number of pods in soybeans and chickpeas and fruits and chilies in this particular study. And they found that it increased and improved yield by 17, 30, and 25% respectively. The untreated plants under the water deficit stressors. Massive results in soybean, chickpeas, and chilies. Moving on to something else that helps significantly reduce drought stress, seaweed. Right? Seaweed's been around for ages. We know it's an extremely effective biostimulant. In this article here, a seaweed extract-based biostimulant mitigates drought stress in sugarcane. So this article is specifically looking at sugarcane. In this instance, leaf analysis showed that seaweed application efficiently improved metabolic activity, as evidenced by a decrease in carbohydrate reserve levels in leaves and increase in total sugars. By positively stabilizing the plant's cellular redox balance, seaweed extract increased plant biomass production, resulting in an increase in energy generation. Thus, foliar seaweed extract application can alleviate drought stress while enhancing the sugarcane, in this instance, development, stock yield, sugar production, and plant physiologic and enzymatic processes. They're finding that the rapid response to plant drought that involves starch metabolism is what led to this, and basically a better and most efficient use of carbon via carbon dioxide and the photosynthesis cycle. So here in sugarcane, we see even in a plant designed to produce sugar, seaweed here is increasing its ability to perform under stress. So seaweed reducing drought stress. Something else, wood vinegar. So wood vinegar or pyroligneous acid is a distillate derived from biochar production and captured, and has many amazing biostimulating features, including many benefits as a seed treatment. But here specifically, foliar application of oil palm wood vinegar enhances Pandanus amaryllophaloceus tolerance. Wow, I butchered that. Anyways, in summary, this article states that the use of palm, that fancy word there, oil palm, in this investigation as a biostimulant to mitigate drought stress, applying it in a 1 to 500 dilution at 3-day intervals for 12 days improved growth parameters. And although the imposed drought decreased stem circumference, leaf structure, and pigmentation, so had a significant impact on the actual size of plants. Even though it had that, it said alleviated these adverse effects and increased reactive oxygen. The increase in reactive oxygen species, proline, and MDA contents, antioxidant activities, and drought responsive gene expression in drought stressed plants were reduced. So in this instance, it's showing, this article shows that wood vinegar, in this instance from oil palm, directly decreases drought stress, and in particular ROS, reactive oxygen species. Reactive oxygen species, when present, can impact the plant through photoinhibition and photooxidation. Both are extremely negative. Basically, it prohibits our plant from photosynthesizing. Big problem, right? Then moving on, so those are biostimulants. We talked about soy hydrolysate. We've talked about seaweed extract, pyroligneous acid, or wood vinegar, and now just briefly touching on a few nutrients. Silicon, thankfully lately has really been getting a lot of the traction that it deserves. But here in this article, functions of silicon and plant stress response, it states that silicon regulates leaf water loss under drought stress. Numerous researchers have shown that silicon application regulates gas exchange, which in turn contributes to drought stress tolerance in species such as maize, soybean, cucumber, and alfalfa. This ultimately resulted in increased water use efficiency and the alleviation of drought stress. I mean, this is incredible. It also goes on to say that it thickens the cuticle, which protects it and increases its photosynthetic ability, and it increases auto regulation. So, I mean, how massive, right? So silica, which can be applied foliar, there are many different forms: potassium silicate, calcium silicate, or even we have a silica product that's derived from a quartz silica. Incredible benefits to plants, and this is just touching on drought stress, not to mention its benefits in staving off fungal infections. Now, maybe even lesser known here, selenium supplementation and crop plant tolerance to metal and metalloid toxicity. So in this study here, selenium supplementation can restrict metal uptake by roots and translocation of shoots, which is one of the vital stress tolerance mechanisms. Selenium can also enhance cellular functions like membrane stability, mineral nutrition homeostasis, antioxidant response, photosynthesis, and thus improve plant growth and development under metalloid stress. So if you're growing in soils that have high levels of metals, but not even so, like we know that plants take up certain levels of metal ions, and many of these are required for sure, but it doesn't actually produce a toxicity, and we certainly don't want that, because the amount of reaction oxygen species that are created, again, as well as other inhibitions from just basically what am I trying to say, from antagonism, can become just a massive. And so we find when we apply selenium, we often see those restrictive or those toxicities reduced, and we wonder if it's helping the plant regulate on its own. Also, as a side note, selenium is required as a precursor for glutathione production, both in plants and animals, which is huge for us. As we know, glutathione is so bioprotective for our liver, and in plants also helps to detoxify our plants and help, again, to reduce those reactive oxygen species. So what's the takeaway? The takeaway is, guys, we have a lot of tools to reduce our stress. So oftentimes, I think adverse situations allow us to learn and improve ourselves, and then better ourselves for when situations improve. So let's use this as an opportunity. Let's think outside of the box and look at tools that we can utilize to reduce our plant drought stress. The amazing side effect of this is all of these biostimulants or nutrients that I've mentioned also have side effects, which is they all also are important for and increase plant cellular growth, fruit quality, root growth, et cetera, right? So it's not like these things are not one note. They're not single function. They contribute to the reduction of plant stress in this manner, but they are essential for, they're cofactors for, on, for so many other things. And so I would like to encourage you, when you go out there and you're thinking about, how do I manage my water? Yeah, absolutely. Let's manage our water as best we can. But let's start asking other questions like, how do I increase my plant's proclivity to resist that stress, or how do I increase the water use efficiency in my plants? As Soilcraft, we do our best to combine all of these and put them in a nice, tidy, logistically feasible and affordable package, because we've seen the benefits over time of multiple dimensions rather than one note, rather than just apply soy hydrolysate and you'll see reduction. Absolutely. Apply wood vinegar. Absolutely. Apply selenium. Sure, I guess, in very small amounts. Be very careful. We use plant sap analysis and lean on that quite heavily. My point being, we've seen much better results when we layer these things, when we combine them. And so that's what we do with our product blends. We are doing our best to combine these so that we're able to hit the plant and help the plants exercise their physiology at so many levels. Because look, the truth of it is, the creation that we operate in, the plants, the animals, everything, the systems are so unbelievably well designed. So many ways to self-regulate, etc. And so let's do our best to go in there and support and steward these systems. That's what we're doing. So I hope you find this useful. Reach out to us, give us a call, hit us up on our email, etc. Visit our website for more questions if we can answer. And I hope you enjoy this podcast, this short form podcast where we just touch on a relevant topic that we happen to be dealing with in the here and now. Thanks very much. Godspeed. Hey, thanks for tuning in and watching our content. We really appreciate you and appreciate you watching our videos. Please like and subscribe if you like what you're seeing here. Also, look down in the description down below for our website, link to our Regen Agronomy podcast, and our phone numbers and email, etc. Reach out to us, please, if you want to know more about the content you see here in the videos.